pretty crazy around here, even though it's snowing everywhere today, but you get like off the lake and it's just, we're got like water on both sides. And my name's Eric Lapp. I'm the ride maintenance manager here. This is Zach here. He's actually the foreman overseeing winter maintenance in this shop here. As a ride maintenance department, we have two different shops. We have about a third of our guys here in this main shop. It's kind of our headquarters during the summer. And in the winter, we have another shop across from Castaway. If you guys look on the other side of the road, Castaway, there's a sign that says the Amazement Shop. We have the other 2/3 of our crew out there. We have about 44 full-time ride mechanics this time of year. And so they're out there rebuilding rides. We're in overhaul season. You see various cars around here in different stages of disassembly or reassembly. So we bring them in, we tear them down, we do all required non-destructive testing, inspection, clean parts. We do a lot of non-destructive testing. It involves checking the chassis, checking the wheels. Could be X-ray, could be dye penetrant. We use a bunch of different styles of that type of method. But after we're done with that, we put everything back outside, and then we wait for the springtime until we put them up on the ride. So, just to give you a little tour here, we got a paint shop here. So after we're done checking the chassis, we tend to wire brush like a lot of paint off or do some repairs or something in here to repaint it. This is the weld shop over here. We got a couple of full-time welders that work on these rides. The other side of the shop's our tool crib. They're working on the Millennium over there currently. On this side, they're doing the Maverick. It's kind of like an assembly line. We start at one side, we take them apart, move over to the other side, and put them back together. So who can tell me what ride that's off of? Any guesses?
Maverick. Maverick.
Maverick. 10 points, you get 10 points. Who can tell me what this is off of?
Gatekeeper.
You're right, you're right. It is Gatekeeper, but it looks very similar to the wheels on like Manus or Raptor as well. So for another 20 points, who can tell me what the difference between this wheel and this wheel is, and why?
Well, there's a softer wheel, like to slow the trains down some, and then the other one has got the thinner tread on it to make it a little faster, a little less resistant.
Less resistance, there you go. So what we have here is a lot harder wheel. What we have here is a lot softer wheel. See that? This one is a lot harder, it's a lot more brittle. And she hit it on the nose saying that there's less resistance. And so what we'll do on some rides, and Gatekeeper especially, we'll put some nylon wheels on and some polyurethane wheels on, some urethane wheels on to control the speed. We don't want it going too fast, but we don't want it going too slow so that it makes it around the track. So Gatekeeper actually has half urethane and half nylon wheels on it. In the morning also, if you ever see them, if you ever get here early, you'll see us testing the rides, and we'll put more weight in the cars to make give the whole train some more momentum to get it around the track, especially when it's real cold out. Water gummies, we call them. A lot of times when it's really cold out, we'll fill up the whole train with these water gummies, these weight bottles, these water bottles, to get the train to go around the track. These wheels, some rides go through a lot more wheels than others. These wheels tend to wear out a lot more than these. Of course, you know what the difference between Raptor and Manus and like a Millennium, how they sound. Which one's louder? Raptor's really loud. Manus is really loud. Ruger is really loud. Actually, we're trying to put some urethane wheels on Ruger. We got some testing wheels, so hopefully we'll be able to put half urethane, half nylon on Ruger too. Hopefully it'll make it around the track. but we can only do that by testing the ground. Also, you'll notice that like Gatekeeper has sand in the column, so that actually requires a column. All right, for another 10 points, who can tell me what this red thing is here?
That's the catch car for the dragster.
You got it, dragster catch car. This device is the hookup point to haul the train, right? But its most important job is slowing down the inertia of the launch system. And who can tell me what this has to do with slowing down the inertia of the launch system? This thing weighs 2,000 pounds. The wire ropes connected to it weigh probably 2-3 tons. The winch drum weighs 16,000 pounds. How it reels in. The hydraulic system turning it. That drum, that 16,000 pound drum is turning it at 540 RPM. All the gears and motors connected to it. What does the catch car have to do with slowing that down?
It's got a set of brakes on the end of it, so when it's going 100 mile an hour at the end of the
What kind of brakes?
They're magnetic.
Magnetic brakes, he's right. This whole assembly is basically an encasement for magnets. Inside here, there's a whole bunch of rare earth magnets. It's from there till about here, it's just magnets. There's two rows of these magnets, and they react on the fins on the track. The fins are made up on dragster of a copper alloy, like a copper and tin composition or a purely copper composition. You go to twister, there's aluminum fins. Basically anything that's conductive and not magnetic, you can put up there. If it was magnetic, it would cause the fin to kind of, it's just like a magnet on a piece of metal. It's fairness of gravity. So the more conductive it is, the higher the efficiency of the magnet. So I need a couple of volunteers, a couple of strong guys. Who's the strongest guy in here? Just a couple of volunteers. It can be girls too. Oh, that guy, come on over. Come on over. All right. Stay right there, my friend. All right, that's good. All right, so here I have a piece of aluminum. This is your ordinary run-of-the-mill aluminum you buy at the steel store down the street, right? Similar to the aluminum fins on Twister or Maverick or Gatekeeper, etc. So, and then on dragster here, I have a magnet. These are the magnets that are mounted to the train. You can see how there's a very small gap between the magnets. And that's because the magnetic field loses strength the further you have them apart. There's a south on one side and north on the other. So this train has fins on both the launch side to slow it down after rollback and the finishing side to slow it down at the end of a normal run. And it goes to those fins anywhere between 100 and 110 miles an hour when it's starting out, right? So this fin rides in here, and could you just pull that straight out for me? Go ahead. As fast as you can. Keep going. Faster. Oh my gosh. So what happens the harder you pull?
It gets more tighter.
Pull. Stop. A lot more resistance. So I can actually push this through here with just 2 fingers slowly. But when they started pulling it, the harder they pulled it, the more it resisted, right? And that's what these eddy current brakes do, is create you can actually see when I put that down there, it actually floats for a while and then it'll settle down. But that's what these, thank you very much guys. So the quicker you pull on it, the more it resists the direction of movement. And the great thing about these brakes, which is the same thing, same concept here and there, slowing the train down or slowing the hydraulic system down, the catch car down, is no contact friction. It's not like the brake pads in your car. So your brake pads grab your rotor, your rotor's going through there, your brake pads grab it, stop it. That's physical friction. These create an eddy current. It's magnetic field that creates the force to oppose your direction of travel and slow the train down. So if we had to have like car type brake shoes on all these rides that went from 100 miles an hour down to 0 miles an hour, it's like starting every minute slamming the brakes on your car from 100 to 0, from 100 to 0, however long it takes to get a train around. And so it's a great technology that's really allowed us to you know, create these coasters that are bigger, faster, and more reliable, and easier to maintain too. Although the magnets are a lot more expensive than a traditional brake. But
By comparison, you got a bunch of 50-mile-an-hour rides that have friction brakes on.
Yep.
How long do those brake times last by comparison?
He asked how long the brake pads last on a traditional coaster, like a Magnum, Corkscrew, that type of thing. And it all depends. You know, Corkscrew comes into the brake run very slowly. Those brakes don't wear out very much. You know, Magnum comes into the brakes above the road pretty fast. So every time, it's friction that slows it down. You know, that train weighs 10,000 pounds, right? And then the people in it weigh another 6,000 pounds. So you're slowing down 16,000 pounds, probably more than that, each time it goes around. So it's a very, it all depends, but very often we replace those brakes, the wear material. It's just like the on your car, the brake pads. So down to the business end of this, you can notice that, this is actually the wire rope here. This is a portion of the 24mm wire rope that actually pulls you. There's two of them side by side that hook up to the front of here. This is actually the cable holder. And this is what winds around the winch drum. It's on the hydraulic room. You guys ever stood next to the hydraulic room when it's launching here, like whiz, wind up, like 3 seconds and wind down? This is what wraps around that winch drum. It's connected to 32 double gear motors. Yes, sir.
How many of those do you get?
Say that again?
How many of those do you get?
The motors?
Cables?
Oh, cables. We change them 3 times a season. They last about a third of the season. And they're very expensive to change. Every time we change them, it's $70,000 or something.
Yeah.
Plus and about 14 hours.
Plus labor and time. But we're real good at doing it because we shut the ride down maybe an hour early and then we open it up an hour late. So you'll come in the morning and they'll be, just finishing up the cable change. We've gotten to the point where we can almost cram it into a night. It's a long process to do it.
Okay.
But,
now, what's the cable made of? Is it like stainless steel or galvanized steel? What kind of?
just plain steel. Just plain steel.
Hardened steel, carbon.
Yeah. Alloy steel, but it's nothing real special. It's a normal wire rope. You can buy those anywhere.
I would think it'd be special steel because it used to pull the train so fast.
It's a
Okay,
hard
so
steel for cables.
the train comes back here, and when you launch, this catch bar is right below you, right? So the dog, which is actually sticking up the train, you can't really see it from here, drops down into this pocket, right? Pushes up, and when you start to launch, you see a couple of things happen. First thing is, your lights turn green up there. Then when they push the launch buttons in the operator booth, the train does what?
It rolls back some.
That rolling back is actually the train releasing the train dog, dropping down in this pocket, and then this block here is what stops it from moving forward. Once it's locked into here, it pushes this switch down that's in here, and that tells the control system that the train is locked and it's ready to launch. At that point, you see all those brakes go down, right? You hear like a loud air whoosh. All those brakes go down. It's like 400 of them, exactly like that. And when all those brakes are down, when each of those 800 limit switches connected to the 400 brakes, connected to the 400 air cylinders, connected to the 200 air valves, all work properly, and all those brakes go down, and it tells the computer that each one of those limit switches sees the breakdown. Only then it's ready to launch. There's a lot of things that have to happen, switches that have to be made in order to launch the train dragster. And that's all automated in the computer system and it's redundant as well.
That's why I like dragster coming out because of all these components, like maybe something else.
Now would you think the dragster with those 1,600 moving parts I just said would be more complicated and would go down more? switches in it?
Yeah.
That's exactly the point. That dragster has so many moving parts. He wondered why, you know, he basically asked me, do parts break? Like, yeah, I mean, the parts are gonna, a limit switch can only go up and down so many times before it wears out. And dragster has 800 of them. It has 300 proximity switches. It's an electrical switch that turns on. That's 400, you said 400 of those moving brakes?
Yeah, 400 moving brakes.
And they all have to do, in order to, you know, show the safety system that it's okay to launch and everything's okay for the ride to go, every one of those has to be checked, and the PLC, redundant PLCs, check all of that and make sure it happens. So to answer your question, yes, you're right. She asked, how do we diagnose a bad limit switch, for example, or a bad proximity switch? Yeah, the computer will tell us, hey, this limit switch, which is located in this position, isn't functioning properly. So then we have to shut the ride down, go out there, and fix the problem, whether it be whatever it may be. But the ride's designed so that all of the safety aspects of the ride are monitored. So the ride probably is still safely operating, and all the components are, but the monitoring system, maybe that limit switch, you know, reached some of its cycles. And it cycles a lot every day. Yes?
I was going to ask another question. How do you get this into place? You use a crane.
That's actually what the 59 there and down there is for.
Yes, sir.
What's the most expensive car dragster?
What's the most expensive car dragster? Reading, Zach.
Hydraulic car.
You said the hydraulic room? There's a motor, hydraulic motor sitting back there. It's a red motor for dragster. And we actually replace 5 of those a year. It costs tens and tens of thousands of dollars to replace all those every year. And that's only one part of the system. Train parts are very specialized. Shafts. This catch car is very expensive. We did the magnets a couple of years ago for hundreds of thousands of dollars. And if you wonder why your ticket's so much, that's fine.